For this polynomial question, most of you should find the first part quite easy. So make sure you don't have any careless mistake in the first part. So you are given a polynomial, and then you are given a remainder of 6 when it's divided by x minus 2. So this question is a very simple one of applying your remainder theorem. So when you apply your remainder theorem, you set the divisor to 0, you get x equal to 2. That means if you put in 2 into the function, then the whole thing will actually serve you the remainder. So most of you should be okay, and you should be able to get k equal to 20. Okay, then in the second part, they change the value of k. So when they change the value of k, do write the new polynomial expression first. Okay, so this will be the polynomial expression that I'll be dealing with for part B. Okay, and for this polynomial, you are given a quadratic uh, factor. So this quadratic factor I cannot break it down to linear factor. So sometimes when they give you quadratic factor, you can actually break it down to linear ones, and then we can work from there. But in this case, it's not possible. It's not possible for you to do a long division either. So can you imagine you try doing this? You try doing this and you try doing a long division. It will not work because there's a unknown in the divisor. So your long division cannot work. So in this case, right, we will need to use the compare coefficient method. So in the first place, right, you need to be able to understand if let's say what will be the breakdown of the cubic equation. So the cubic equation has this as a function, has this as a factor. So this is a quadratic factor, and the polynomial is cubic. So I will expect that I will get a linear function here. So if I am able to do a long division, I'll be expecting a linear function in the quotient. So linear function will be something like ax plus b. Okay, however, if you look, the linear function that I got, I just put it as x plus b. Okay, how do I know that it will be x? Because if you look carefully here, if you multiply this, 2x squared and this, okay, I cannot do a full long division, but I can do a little bit of long division with the first one. So if I do a little bit of long division, it will have been x. So x, then I will continue something like this. So it's just that I wouldn't know the number. So because of this, my polynomial is set up as a quadratic multiplied by a linear. And the linear will be x plus b. So this is how I set it up. So I couldn't do a long division, full long division. So I will set up using the idea of comparing coefficient. Okay, so before I go and compare, right, let's just make sure you understand this part first. So for the cubic equation, I break it down into quadratic and linear. Quadratic is given to me. Linear is what I deduce out. So how I know it will be deduced, how I know it will be a linear function. So if I'm able to do a little bit of long division, my quotient will be linear because of 2x squared times x will give me a 2x cubed. So I will know that my linear will be x plus a number. And the number is unknown, so I'm going to let it be b. Okay, so from here on, it's a little bit like your binomial, where you do a bit of compare coefficient, but the comparing is very easy. The comparing is the easy ones. So for example, right, this will be the one that gave me the constant. So this will be the one that will give me the constant. Those who are not very good with this, you can explore out all the arrows. Okay, you can explore out all the arrows you will find that there are 6 arrows. And out of the 6 arrows, the only one that can give you constant will be -3 times b. And this -3 times b will be equal to -6 here. So that's how I gotten my b to be 2. So once I gotten my b to be 2, I will write out my polynomial again, and I'm going to compare. You can choose to compare coefficient of x, or you can choose to compare the coefficient of x squared. So in my working, I'm comparing coefficient of x. Okay, so I'm comparing coefficient of x. Okay, later on I will show what if you decide that you want to compare coefficient of x squared. So if I would like to compare the coefficient of x, look for the arrows that can give you a x. So this multiplied by 2. Okay, this multiplied by 2. So ax multiplied by +2. That will give me the 2ax. And a constant multiplied by x. That will give me the -3x. So where do I get the comparison? I will get it from here. So in the function, the coefficient of x is -13. So I will compare it to -13. Then after that, you drop all the x. So when you drop all the x, right, you can compare to get the a. So that is how you find the value of a. So the question asks you to find the value of a. So once you get the value of a, okay, that's it. But in some cases, right, you might be asked to further factorize the whole polynomial. Okay, so that's possible. So I'm going to show you what happened when I decide that, let's say I would like to do a compare coefficient of x squared. I will still get the same answer. So which one will give me x squared? So this and this. So I will have a 4x squared. I will this and x. So I will have a ax squared. And that will be equal to the -x squared. So again, you drop all the x squared. You will still get the same value of a if, let's say, you choose to compare the coefficient of x. So they are exactly the same answer. Okay. There is another alternative method from one of the students. So I roughly explain the other method. Okay, so after the k equal to -6, so some students, right, they see it as a cubic equation. So they see it as a cubic equation, then they do the trial and error. So some students, they will do the trial and error. So for example, if you do the trial and error, I think if you do the trial and error, I'm just going to do a random one first. 2 minus 1 minus 13. Okay, I think okay, this is from one of the other student that I got. Um, okay, let me find a factor. Um, okay, hang on now. I have a direct factor, but I didn't want to use that first. Okay, I want to show you this idea. Okay, So I did a trial and error. I got this to be a 0. So this one came from one of the student that I marked. So this student, right? Okay, so from here, this is a factor. So what the student did was, the student did it like a normal cubic equation. So the student did it like a normal cubic equation. Eventually still get the same answer, and it's the correct method also. So I'm just showing to all of you. So this is the generic method, right, of handling a cubic equation. Okay, so how, so if let's say you do it by the normal polynomial method, this is what you will have. And then your conclusion will be, it will be a x minus 3. And then this one will be a 2x squared plus 5x plus 2. Okay, so the student were trying to attempt to compare. The student were trying to compare with the quadratic factor. So, okay, this student, right, she did like a normal cubic equation. After that, she tried to compare with this one. She tried to compare. Her thinking is actually correct, but in this case, we cannot compare for the pure reason the coefficient doesn't match. This is a minus 3. The constant doesn't match. So actually, we cannot compare. So we cannot compare here. So what you should do will be, what that student should do will be, the student should continue to factorize first. The student should continue to factorize. Okay, hang on. Mm. So it will be something like this. So the student should continue to factorize first, and then right, try to get a quadratic that looks like this one. So try to get a quadratic that looks like this. So the quadratic that looks like this will come from here. So the quadratic that looks like this will come from here. And then she can compare. Then she can compare and get the answer to be a minus 5 also. So this is another alternative method. So you can approach it like a normal cubic equation. So you find a factor, go through the long division. So eventually you want to get factor, but the factor must have this same coefficient, not like it must have the same constant for you to do the comparison. Otherwise, it's not correct. Okay, so it can be this method, or you can do the setup like I mentioned here, then do the compare coefficient.